back again, like we never left, let's continue. I like to move it. I like to move it. I like to move it. You like to move it. Boom, 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 boom. Physically, like I said, these tensions, they are not acting in one direction, right? So they're acting in both the Z direction and the Y direction. Okay, so we have to find these components, right? So it's gonna be same. They made it easy for us. They're giving the angle, right? Look at it. That's sexy angle, 25. 25 degrees, right? 25 degrees, and this is the resultant tensions. This is gonna be T1 plus T2. So I'm gonna call this Ty, and I'm gonna call this nigga TZ. Let's find everybody. Let's find me. Oh, find me. Or T1 plus T2 is gonna be, we found those tensions, right? So T1 is gonna be 1017.366 plus 2247.36. I like to move it. I like to move it. I like to move it. You like to move it. Like, okay, T1, let's focus, plus T2 is equal to 1017.366 plus 247.306. Okay, gives me 1264.672 Newton, right? And then trigonometry, grade 10, sine 25, right, is equals to the Ty over T1 plus T2 is going to be 1264.672. So that means my Ty is going to be 1264.672 sine 25. And then my Ty, and then my TZ is gonna be the same thing, but then it equals 1264.672 cos 25, right? I like to move it. I like to move it. 1264. 1264.672 sine 25. You like to move it. 534.47 Newton. 534. Okay. Physically 1146.18. They both tension, so they're in Newton, right? Okay, we getting there. We getting there, break by break, like I said, break by break. Now let's draw the shear stress diagrams, right? Now, first things first, we're gonna focus in the y direction, x and y direction. You draw him, draw the shaft, draw him so that we can see him. I want to see him with my own 2 eyes, bro. 2 naked eyes. Yeah. So let me check the question. Check the question. What do we have here? We have, in the y direction, the bearing will always go up, right? So yeah, bearing, and then we have bearing, right? And then okay, and then the radial force of the gear will go down here. Yes, the radial force. And then okay, let me check something. these tensions have been pulled. This nigga outside, it's making noise. But then, okay, the tensions, in which direction are they going to go? Because if I look at this, right? Okay. Looking at the tensions, the first thing that comes into my mind, right, is that they are being pulled upwards, right? They're being pulled both upwards and on the sides, right? And another thing that comes to my mind, right, is that this pulley and the key, like, they've been driven in the same direction, you see, in the anti-clockwise, right? So me, what will I say here? They both want to be pulled upward. Okay, my first assumption would be to put this tension in the upward direction, but then if they're being pulled in the upward direction, right? Okay, let's think about this. Let's think. Okay, if they're being pulled in the upward direction, right? Because sometimes you have to use basic intelligence, right? You don't have to be in grade 12 to know this. But then these forces, okay, they both in the same direction, right? And then this one we are sure that it's going down. That one we sure that it's going down. So I feel like this one, I think he should also go down, the pulley, right? I think he should also go down. It's fair that way. Okay, I'm gonna put him, we'll see what happens. I'm gonna put him as if he's going down. Okay. 0.3, let's write the distances. 0.3, 0.16, right? And then here we have RAY, here we have RCY, and then here we have FR, and then here we have TY, right? We're not given no weight is given, so we don't consider any weight, right? Okay, these are the distances. Okay, let's find the reactions. Up. It's equals to RAY plus RCY is equals to FR plus TY. What is that? That means RAY plus RCY is equals to FR. What's my FR? The radial force on the gear, right? The radial force on the gear is 778.55, right? Plus T1. What is my T1? My TY is 534.47, right? Okay, and then you take in moments about A. So it's gonna be RA multiplied by 0.6 is RAY multiplied by 0.6, right? Going in the opposite, it's gonna be minus FR. FR is 778.55 multiplied by 0.3, right? And then this one is going the opposite direction, plus TY, which is 534.47 multiplied by 0.16. So that means RAY is 0.6 man. 0.6 RAY is equals to minus 778.55, 0.3 plus 534.47 0.47 multiplied by 0.16. It's gonna be minus, and then coming in here is gonna be 148.04, right? And then we divide by 0.6. 0.6 dividing by 0.6 RAY gives us 246.75 Newton, right? And then that means RCY is equals to everything minus this one is 778.55 plus 534.47 minus minus 246.75. That means our RCY is 778.55 minus 534.47 minus 246.75 is minus 2.67. I wonder, why did I make a mistake? It's plus, but it's 778.55 plus 534.47 minus 246.75. Gonna be 1066.27 Newton for an RCY and for an RC. And so let's draw the shear stress diagram. We're moving faster, we don't have time. Okay. The XY, let's draw it. I want to see it with my own eyes. I want to see. Fucking niggas making noise. Okay, let's go. So he doesn't even know how to sing. But then let's forget about that. Let's spread positivity. He knows how to sing. Okay, Y RAY is equal to 2 is 2 4 RAY, and then FR is 778.55, and here RCY, and then here TY is 534.47, right? And then let's draw the shear stress, nigga. The shear stress. Okay, this is gonna be where our shear forces be, and it's gonna be our bending moments. Alright, shear force PMW, right? Okay, this is gonna be distance 0.3, 0.3, 0.16. The shear force RAY is 246 pm, 246.75, and then is right, like the aviator eating your money. 246.75 minus 778.55. It brings us to minus 531 is minus 531.8, right? And then we go up again. We go down, go up, down, plus RCY, which is plus 1066.27, right? Gives us 534.47 is 534.47, right? And then it comes here, and then it comes back to the egg, to 0. Okay, sorry about that. Yeah, this is our shear force, blah blah, bam 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 bam. And then let's right? Our bending moments, So this is A, this is C, and then this is C, and this is B, and then this is D, right? And then bending moment at A, at B, at C, at D. Nigga, everybody knows this, 0. Everybody knows this, 0. Right? And then the bending moment at B is gonna be 246.75 multiplied by 0.3. 246.75 multiplied by 0.6 minus 778.55 multiplied by 0.3. Pow. I'm moving fast, né? 246.75, 0.3. It's gonna be 70, let me just say 74 Newton meter. And then here is gonna be minus 778.55, 0.3. Pow. Gonna be minus 85. I'm gonna write it here, right? Bending moment at C. It's gonna be minus 85.515 Newton meter. Pow, right? And then let's write them 74. I'm gonna put it here, 74. And then here is minus 85. I'm gonna put it here. It's minus 85.515. Pow, right? Okay. This nigga comes here, and then he comes back to 0. Right? This other one also comes back to 0. Right? So connect everything. We're getting there. Brick by brick. Brick by brick. I said, what is the best word ever came up with? Eventually. You're gonna get there eventually, right? Now let's focus in the Z direction. X, Z. Eventually we're gonna get there. Yeah. Brick by brick. So let's draw this. Let's draw this bumper cloud. Okay. In the Z direction, we don't know where the bearing is. Asiyazi ukuthi is 18 upwards or downwards, upwards. But we're going to assume, right? But then another thing, one thing that we know here, right, is that these things, the pulley and the gear, they're moving in the same direction, right? So that means what? That means the tangential force and these tensions, they have to act in the same direction, right? They have to act in the same direction. Yes, they have to. That's true. Okay, I'm gonna assume that this I'm gonna assume what? What are you gonna assume, brother man? Okay. I'm gonna assume that this is going up, right? And then the gear, like I said, the gear and the pulley, they have to be in the same direction, right? Because they're turning in the same direction. And then here, right? And then here, just to let things balance out, I'm gonna assume that these bearings, they are both acting in the opposite direction as these forces here, right? So this is gonna be R, B, C, and then D. Okay, and then this is gonna be R, A, Z. It's gonna be R, C, Z, right? The distance is 0 0.3, 0 0.3, 0.16. Bam, 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 bam. Yes. Kapow! I like to move it. I like to move it. So this is gonna be the tangential, and this is gonna be the TX, right? Let's find everything. We like to move it. So R AZ plus R CZ is equals to FT plus TX. It's like text. Yeah, it's fucked up. Text. Okay, now let's find RAZ. RAZ is 030 is RAZ multiplied by 0.6, right? Minus FT. Let's check for FT. Let's check for FT. FT we found them is 2139.07 multiplied by 0.3, right? And then plus this one plus TX. TX is how much? TX, I found him recently. Now where's he? Is he running away from me? Bro, do you really think that you can run away from me? Huh? Is that what you think? Is that what you think, huh? Huh? You ran away from me. Okay, TX is, I mean TZ, man. TZ, what did I? So yeah, TZ. So TZ is gonna be 1146.18 multiplied by 0.16 is equals to 0. Let me find the RAZ, right? 0.6 RAZ is equals to mashallah minus 2139.07, 0.3, and then plus 1146.18, 0.16 minus 213.0. Okay. Okay. Minus 48.458.33 over 0.6. That means R AZ is equals to 0.6 is equals to 763.887 Newton. That means our R CZ is equals to this one, FT, which is 2139.07 plus TZ, which is 1146.18 minus 763.887.